Like Alice said, my name is Melissa Stone, and I'm a release engineer at Puppet Labs. What my team and I do is we don't build the software. We build the tools that build the software. So I've been working at Puppet Labs for just over a year now with the release engineering team. But before that, I was an undergraduate at Lewis and Clark College studying psychology and computer science. So yes, I am analyzing every single one of you right now. Just bear that in mind. So now you know a little bit about me. Let's get started. So let me propose to you a situation. You have been working on a tool for a while now, and it's finally ready. You're ready to get it into the hands of your users, onto production systems, and for other people to play around with it. How do you do that? Something like this? Right? Yes? No. Maybe you compile your project on your system and then tar up those compiled binaries and send them out to your users? Maybe? I hope not. I hope not. Hopefully you package it. And if you don't, I'm sure you probably have some hesitation. I mean, after all, people can totally just build from source, right? Well, you know, not everybody can. Not only that, but every project builds slightly differently. So they're going to have to build your project. They're going to have to dig through your documentation. They're going to have to find out what dependencies you need. That's a lot of work, and that's a huge barrier for people to use your stuff. All right, well, you might be thinking, well, packaging, it's too much learning. There's too much to learn in that arena. Well, there is a lot to learn, but learning is so much fun. That's why we're in this industry, right? We love new things. We love new toys. We love to figure out how to make things better. Not only that, but there's a steep learning curve. Once you learn how to package for your first system, the next is that much easier. And it only gets easier from there. You might be thinking, oh, you know, nobody really cares about packages. Nobody wants my tools packaged up. There's no demand. My users aren't pounding down my door trying to get packages. You would be surprised. They may not know that you have the time or the capacity to do that. And once you start providing them with packages, they're going to be like, oh my gosh, this is the most amazing thing ever. Can you package for this system, and this one too? They're going to be so thrilled. All right, well, it's too much maintenance. There's too many things going on. It's just too much overhead. Well, packaging does incur maintenance costs. That's, you know, a thing that happens. But as soon as you start packaging your software, people are going to, you know, file bugs against the packaging, and it's going to be this whole big deal. Well, I think it's worth it. Like, once you get to know the packaging systems, maintenance becomes easier and easier. You're going to know where things go wrong. You're going to know how to make it the best experience possible. And you might be one of those lucky few who have somebody else who's packaging up your software. Maybe you've got a downstream maintainer, and that's awesome. You're so lucky. Well, you know, it's not always the best idea to rely on a downstream maintainer. They're great. They're awesome, and usually, you know, they keep up with everything, but they're also packaging up other projects. They're not solely dedicated to your work, so they're not going to get the updated package out right away. They're not paying attention. They don't care as much as you care. That's not all downstream maintainers, but, you know, it's not great to rely on that. Just to emphasize that point, I think one of the best examples of this is with Puppet on Lucid. So if you're a Lucid user, they are a downstream maintainer of Puppet, and the version that they provide to users is 0.24. You don't really want to use that version of Puppet. If we weren't packaging up Puppet for Lucid, you really wouldn't have any other good options. So instead of getting Puppet from Lucid, people go to our repos. So now that I've eased some of your concerns, let me go on to extol more of the benefits of packaging. So if you package your software, you're gonna allow your maintainer or your users to maintain clean, or at least cleaner, production systems. All of the build tools that you need can live on your builders. They don't have to live on the build system. So that's awesome. Not only you're saving space on your production system, but sometimes, some places, people can, or some build tools are considered security risks or security vulnerabilities. So that's awesome that you don't have to have those on production systems. You also get project versioning. You get to version your stuff, which is great. You can install a specific version if you need it. You can downgrade if whatever version you're on isn't working. You can upgrade if you want to. That's awesome. Along those lines, you can also uninstall. Uninstalling is awesome. It's kind of hard to do that, you know, when you're building from source, unpacking a tarball. Along with that, you get file ownership, so you can know what packages on what files. That makes it pretty easy to uninstall, because a package will know what files it needs to clean up. And you also can have pre and post install and uninstall actions. So if you need to make sure a certain user exists on the environment before installing, you can do that. Or if you need to make sure a certain script is stopped before uninstalling, you can do that. You also get dependency resolution. So remember this? You would have to do that for every single dependency that you needed on the system. Whereas with packaging, most packaging systems can handle dependency resolution, and they'll just automatically install the dependencies that you need. This means that as the package maintainer, you can specify a certain version of a dependency that you might need, which is super useful. Not only that, but you get user confidence. So if I am running on CentOS, and you hand me an RPM package, I'm going to know what to do with it. I know how to use Yum. I'm comfortable with Yum. I probably am fairly familiar with the security that Yum has, and I'll have used it before. So that's great in terms of user confidence. Whereas if I'm running on a Windows system and you hand me a tarball, it's not going to be so great. You know, if you handed me an MSI, golden. But tarball, you know, not so much. Great. So in case you're still having some doubts, I want to share with you some statistics. So this is downloads per week over a 6-month period from apt.puppetlabs.com, yum.puppetlabs.com, and downloads.puppetlabs.com. So this is just packages. So deb packages, RPM packages, gems, MSIs, and DMGs. No tarballs in this data. As you can see, we're hovering around 1 million downloads a week. That's a ton of downloads. And you might be thinking, oh, you know, that's just Puppet Labs. Like, that doesn't apply to my system. Well, let's check out tarball downloads. Again, downloads per week over a 6-month period. We're hovering around 10,000. 10,000 is not a number to scoff at. But when you compare it to 1 million, that's a huge difference. People love packages. People are going to be super stoked if you provide them with a package that is meant for their system. All right, I'm pretty sure I've convinced you by now. And so I'm sure you're wondering, like, all right, where do I start? Where do I start with this craziness? Well, at Puppet Labs, we start with the builders. So we use Puppet to provision all of our builders. These are dedicated machines that we use for building our packages. They're clean, they're automated, they're easy to tear down, and they're easy to bring back up. We have these awesome modules called RPM Builder and Deb Builder that you can apply to your Puppetized builder, and it'll bring in everything you need for building packages. So for RPM Builder, it's going to bring in things like RPM. It's going to make sure RPM's on the system. It's going to make sure you've got mocks on the system. In case you don't know what mock is, it's a shroot, a clean environment that we use for building packages. It basically provides an isolated and safe place for building, so it's not going to pollute the builder's environment. For Debian, we use debbuilder, and that'll install like dpackage build package and pbuild, all the Debian tools that you need, as well as cows, if you specify use cows as true, which you should, because cows are awesome. Like mock, cows are a Shroot environment, a clean environment where you can build without polluting your build system. So there are a lot of moving parts with build systems, and these two modules make it super easy to take all of those moving parts and set it up in a sane way for you, which is super awesome. In case you're curious, at Puppet Labs, we have dedicated hardware that we use to run VMs, or that we use as builders. And for our RPM builders, we tend to use CentOS 7. And for our Debian builders, we use Debian 7, or Wheezy. All right, now we've got our builders set up. Yay. Let's talk about our automation. So this is the bread and butter of the packaging side of things. This repo, github.com/puppetlabs/packaging, is where we keep all of that automation. I should note that this was built with our projects in mind and our infrastructure in mind. That being said, we've worked hard to make it so that you can use this on your system. So this repo we wrote this repo with Ruby, which made sense for us since most of our projects are written in Ruby. And we also use rake, which is the Ruby version of make. Rake is basically a DSL or a wrapper for Ruby. So anything you can do in Ruby, you can do with rake. So this automation is great because it is project agnostic, it's data driven, and it's a central location for all of this automation that we use everywhere. So let's get started. So the example I'm going to use today is the mcollective PuppetCA agent repo. The PuppetCA agent is an mcollective plugin, and the reason I'm using it today is because the packaging is fairly straightforward. So this repo is written in Ruby, and they already have a rake file in place, a top-level rake file, which is akin to a make file. And I need to edit it. So I need to make sure that these lines are present in the rake file. After I've edited that file, all I have to do is add in these new files. You can see that all these files that we're using are contained in the ext directory. We've got some YAML files, we've got another rake file, and we've got some platform-specific files, so the Debian directory and the Red Hat directory. So let's take a look at some of these files. So I'm going to start with packaging.rake. So if you'll remember, back here in the rake file that we modified, we add in this load of a file called packaging.rake in the ext directory. So that's this file. This file was copied verbatim from the README in the packaging repo. I didn't have to edit anything, just copied and pasted. Super easy. What this file does is it provides you with the means of accessing the automation that's present in the packaging repo. So it will pull down, it will clone the packaging repo into your project and allow you to access the rake tasks that we use for building. All right, so these are the YAML files that we've got in the ext directory. We've got builddefaults.yaml and projectdata.yaml. So do you remember how I said that the packaging repo is data-driven? This is where it gets all of its data. So here we define the name of the project, the author of the project, the home page, as well as any templates that we need to make sure are processed. We're also defining where it's going to find its packaging automation. We're going to define what cows we're going to build. So remember, cow is our Shroot environment for Debian systems. That also allows us to build a different Debian platform if we want. So if we're on a Wheezy system and we really need a Lucid package, we can do that using cows. So we specify the cows we want to build. We specify the GPG credentials that we're going to use to sign the packages. We can specify the mocks that we want to build for. Again, with mocks, you can build a different system, or build packages for a different system than what you're on using mocks. And then we're going to define where we want these packages to get shipped when they're ready to be shipped. And we also define what we're going to build. So right now, I'm only talking about Debian and RPM packages. But the packaging repo has the capacity to build gems, DMGs, I think a couple others. But we're not going to worry about that right now. So you're thinking, oh, this is great. This is awesome. This is a great file. And I hope if you do want to use this automation, I hope you pay attention to this. But I'm sure you're like, well, what do I specifically need to change in order to get this to work in my own system? Well, if for some reason you wanted to be a downstream maintainer of the mcollective Puppet CA agent, this is what you'd have to change. So you're putting in your own GPG credentials, you're changing where it's shipped to, and you're changing the maintainer of the project. It's very little changes need to be made, which is pretty cool. So let's take a look at the files that we've added. We've gone over build defaults.yaml. That was one of our data files. We've gone over packaging.rake. That brings in our automation for us. And we've looked at project-data.yaml, which is another data file. What that leaves us with is the Debian directory and the Red Hat directory. So I'm going to let you investigate those directories on your own. There's a lot of great documentation out there on the specifics of these different packaging artifacts. The Fedora project wiki has great documentation on how to put together a spec file, all the different sections you're going to need in the spec file. And Debian.org has their maintainer guide, which has a bunch of information on the different Debian-specific files that you need in order to build Debian packages. All right, we've got everything set up. All the files are in place. Let's build this. So we're going to SSH into our RPM builder that's been puppetized and has all of the tools that we need already on it. We're going to clone the project, cd into that project, and then we're going to run rake package bootstrap. So this task is a rake task provided to us by packaging.rake. And what it does is it clones the packaging repo in your project and makes all of the rake tasks in the packaging repo available to you to use. And one of those is rake pl mock. So this task sends all of your build data information, or your data, to mock and spits out an RPM for you. So as you can see, there's a ton of stuff that it's automated. It's going to process any templates that you need. It's going to set up the directories that mock needs available. It's going to make sure all of the directories are populated with the correct files. It's going to then pass all those files into mock, and it's going to build you a source RPM. It's then going to take that source RPM that you just built, pass it into mock, and it's going to build you an RPM package. Once you've got those packages, it's going to move them into the packaging directory, and then it's going to clean everything up for you. All right, so we've got our RPM packages. Let's build some Debian packages. Again, we're going to SSH into our deb builder. We're going to clone the project, cd into that project, run our rake package bootstrap task again. And this time we're going to run rake pl deb, which is very similar to rake pl mock, but it's going to use the deb builder tools and cows to build. So again, we're going to process the templates. We're going to make sure the directories are all set up how they need to be. We're going to make sure the right files exist for the Debian packaging tools. And then we're going to pass all of that in to petabuild, specifying the cow that we're building for. And that's going to give us our Debian packages. We're going to move those final packages into the packaging directory, and then we're going to clean up behind us. So I'm sure you've noticed, but building an RPM package is very similar to building a Debian package. Not in terms of the stuff that's been automated, but in terms of what you have to do. And we did that for a reason, because you don't really want to SSH into a builder in order to build something. That's kind of a pain. And you might have 50, 1,000 builders. How do you know which one is the right one to SSH into? How do you know, what one you want to use? So we took this and we created the Jenkins uberbuild task. This is an awesome task, and this is actually fairly fine-tuned to our infrastructure, and I'm not sure the work that would be needed to port it to your own infrastructure, but I think it's a really great piece of work. This is really cool and has saved us a ton of time. So what it does is it takes all that data you've provided in your YAML files, and it builds everything for you. It will dynamically create a Jenkins job with all of those build targets, and then once it's finished, you've got the ability to specify a downstream job if you want to. So we're actually using this in our build pipeline right now, so we can automatically kick off a build once tests have gone green. And as you can see, so this task was introduced about a year ago, and we went from 8,000 builds up to, when we peaked at over 16,000 builds. And then we realized, we don't actually need to build all of these packages. And that's where the drop-off happens. We stopped building everything, toned back our excitement a little bit, and started only building the packages that we were actually going to use for testing. So this was really fun to be a part of. All right, so you've got these packages. They're kind of hanging out. What do you do with them now? How do you get them to your users? They're on your laptop, or they're on your builder, or whatever. Well, first we should sign them. I hope you sign your packages if you're building packages. Signing is super important. Signing is how your users know that this package is directly from you, that it hasn't been tampered with, it hasn't, nothing weird has happened in between you and them. And also, some packaging systems will whine a lot if you try to install an unsigned package, which is kind of gross from a user perspective. So we've got these awesome tasks that we use to sign our packages. We've got rake pl sign deb changes and rake pl sign RPMs. Sign deb changes will sign the changes file using deb sign and the GPG credentials you specified in the project data. We do also sign the Debian repositories. Not actually the Debian package. That's just how the Debian system and apt has been set up. And then the sign RPMs task uses the RPM to sign the packages using, again, the GPG credentials that we specified in our data. Cool, so you've got your packages signed. Great. Now we've got to ship them. So again, we've got these great shipping tasks. And these tasks will ship your packages to the repos that you specified in your project data. Yay, so now your packages are in place. Now what? Well, you've got to generate your repos. So we use Freight for our apt repo, and we use yum for we use create repo for our yum repo. So Freight and create repo are both tools that are used to generate repo metadata. So this is going to tell apt and yum that the user is running on their system what packages are available in your repo. They're going to be able to tell the user what dependencies these packages have. It's how users can communicate, or user systems can communicate with the repos that you've set up. So these are the commands that we use, or that we run. Freight add, we actually ship Debian packages to kind of a staging location, and then add them into the actual destination repo. And then we run Freight cache to make sure that metadata is updated and signed. so apt can verify that it's ours. And for yum, we ship directly to the repo itself and then run create repo to update the metadata in that repo. So we're back to this. We have set up we've gone through the process that we need to set up our builders, build our packages, sign them, and then get them out to the users. So hopefully now, looking at this kind of makes you like uncomfortable, makes you like twitch in your seat a little bit. We've gone from this to that. I'm going to emphasize that one more time. We've gone from this to that. Super friendly for users. Really great. Super fun. Easy to run. All right. So all of the automation that I just showed you is open source. So you can access the code here. If you want, you can file a ticket. If you want a new feature, if you want to help us fix a bug, you can file a ticket at tickets.puppetlabs.com/browse/CPR. CPR stands for Community Packaging Repository. It's where all of the tickets for the packaging repo live. Or, even better, you could open a pull request and help us make this code better, because I know it's not perfect. I know for a fact. This, again, lives at github.com/puppetlabs/packaging. And if you don't want to contribute, you're no obligation to. It's totally fine. It's just really exciting when users open a pull request or want to get involved. So again, these are the links that I presented earlier throughout the presentation. We've got our maintainer guide for Debian and Fedora. There are links to Freight that we use for our apt metadata generation. Create repo that we use for our yum metadata generation. The packaging repo. We've got the RPM and Deb Builder modules, and again, the tickets repo. Thank you so much all for coming out, and I would love to answer any questions that you guys might have now. It's hard to see you guys, also. Questions? What?
Do you maintain Puppet for the win, and is there going to be any effort to integrate that closer with the other stuff?
So he asked if I maintain Puppet for the win and if there's going to be any efforts to integrate that with the other automation. So Puppet for the win is interesting in that the release engineering team kind of works with the Windows guys to maintain all of that. So it's not just us, it's also them. And there has been talk about trying to get that into the packaging repo, but it's going to be a lot of work. They're pretty different systems. Yeah.
So, two-part question. The first part is, are you actually using Puppet to drive the package building process, or are you using Ruby some sort of script to do it instead?
What do you mean to drive the package building process?
Basically, generate the packages when you automate things, right?
Oh, okay.
What is actually running the automation?
So he asked, what is actually running the automation? And it is Ruby. So we're not using Puppet to drive this, but we do, like I said earlier, we do use Puppet to provision the builders, and it's definitely an integral part of the pipeline because we need builders, and sometimes we need a lot of builders in order to satisfy demand.
And the second question is, when you set up these provisioning things, right? Do you have like a Jenkins repository next to that, or are you pulling the files that you need from somewhere else? Where do the repos reside relative to the package building?
Great. So he's asking where the repos live in relation to the packaging repo?
Yes.
So the project repos are all on GitHub. There's like github.com/puppetlabs/puppet, Factor, Hyra, mcollective, Razor. These all live in GitHub, as well as the packaging repo. And we do use Jenkins to kind of automate more so the building process. And Jenkins knows the location of the project that it's building. So it'll go and fetch that source code and make sure it's present in the environment that we're building on and in that repo. Does that answer that question? Any more? Yeah?
How do you test your packages?
So he's asking, how do we test our packages? So testing is not something that I'm in charge of, thank goodness. We've got a quality engineering team and a quality assessment team. And we also do maintain spec tests and integration tests, a whole bunch of testing suites. And it's slightly different per project. So generally what happens is like spec tests are run per commit, acceptance tests are run, I don't know when. And then we've got a nightly suite of tests that get run. And the nightly suite of tests, if that's all green, and this is all in Jenkins, if that's all green, then that will kick off one of these packaging tasks and make those packages available on our internal build server. So it's kind of a cross-team effort between the developers and QA in order to maintain the tests.
I understand, but the package can go wrong as well, right?
Yeah, so once the packages are built, we try to run integration tests, so where we actually take those packages and install them on the system. I am not exactly sure how automated that is. I do believe that, like for Puppet, that is an automated process. And I think also for Factor, where once the packages are built, after specs and acceptance tests are green, packages are built, the packages are then taken and installed on the machines that are specified. And the developers own that, I think. Yeah?
How do you make decisions about supporting new build targets, like when Utopic Unicorn comes out, or Fedora 21, or one of those things?
Uh-huh.
As far as how much effort it's going to be to support the new Ruby or whatever in those platforms.
So you asked about how we make decisions on adding support for new platforms. So this is, it's different for open source and for commercial. For commercial, it's usually a directive from somebody higher up. But for open source, so right now we're building packages for EL 5, 6, and 7, and Fedora 19 and 20. When a new version of EL comes out, we're probably going to support it. When a new version of Fedora comes out, we're probably going to support it. Other than that, if users are really pushing for support for a new platform, or if we think we want to take Puppet to a new platform, then we kind of have a conversation with both devs and release and QA and some of the execs and make sure that that's actually what we want to do. Recently, we added 64-bit support for Windows. And that was a whole conversation between community and developers and us to make sure that we could do that. So it's not just us making that decision. Yeah?
How do you manage the various different versions of Ruby that are available on some of the other systems, like say 2.0 on RHEL 7 versus the 1.8.7 release that comes with 5 and 6?
So he's asking how we maintain, or I guess support all the different versions of Ruby that are available out there. So we test all the different versions of Ruby. We've got this giant test matrix where we run Puppet and all the different projects with Ruby 1.8 and Ruby 1.9 and Ruby 2.0 and Ruby 2.1. But we don't support anything less than Ruby 1.8.7, I believe. And EL 5, I think ships with 1.8.1 or something like that. Not a recent enough version. So we've actually built a Ruby package and made it available for EL 5 users. And that's how we're currently doing it. Anyone else? Questions? No? Okay. Well, thank you all so much for coming out.